Hi guys, let's solve today's Leetcode problem, and it is problem number 1855, maximum distance between a pair of values. It's a medium problem. Let's read this out. You're given a non-increasing zero-indexed integer array nums1 and nums2, which means it is decreasing. A pair of indices ij where I is in its 0 to its size, j is in 0 to its size, and is valid if both I is less than equal to j and nums of 1 of I is less than equal to nums 2 of j. The distance of the pair is j minus I. Okay. Return the maximum distance of any valid pair I, j. If there is no valid pairs, return 0. An array is non-increasing if array of I minus 1 is greater than equal to array of I for every I. So non-increasing is basically decreasing. So what the constraint that is given for this question is both nums1 and nums2 length can be up to 10 to the power 5 and its values can also be up to 10 to the power 5 and both are non-increasing, which is decreasing. Okay, so this is decreasing. So this is an example where we have given two arrays and the output is 2. So there are given certain valid pairs here, and based on those pairs, maximum distance here they have computed is 2 with pair 2, 4. Okay. So for this question, we are going to cover these three approaches. One would be the brute force, basically what the question is being has asked. We will just do that. Another is binary search, and then the two-pointer approach, which is the most optimal approach for this question. So let's get started with what is being asked in the question. So here if you see what does the question says, it clearly says two things. One is I should be less than equal to j and another is this nums of 1 of I should be less than equal to nums 2 of j. Okay, so this is our nums 1, this is nums 2. Now if we start looking in this, if I see for this value in this is my index j and here is my index I. So for this j, what we need to see if till this index j is this nums of I, is this value less than equal to this value or not? If we see this is less, so this is a valid pair. Okay, so 0 comma 0 is a valid pair, and then we can have the difference. So difference is again 0 minus 0 is 0, so it is again 0, no update over here. Now what we need to do is we need to compute the next pair, right? So we will what we do. Um, one thing is like what question is saying that for every I and j we have to check, right? But if we move ahead, let's say here or here, so here I would be greater than j, right? So we won't move there because our main constraint is I should be less than equal to j. So we will explore till here only. Now let's move our next pointer j here. Now when we see j here, again we will start I from fresh. It's 55. Is 55 less than equal to 20? No. So we will move our next pointer. Is 30 less than equal to 20? No. So if we move our next pointer here, we see that 2 is greater than 1, which is not a valid, which doesn't obey our constraint. So we will move j to the next pointer. Now our j is here. Now again we will start again from this value I, and here we see is 55 less than 10? No. We'll move our j pointer ahead. 30 less than 10? No. Then 5 less than 10? No. Sorry. Yes, 5 is less than 10. Now since 5 is less than 10, this is our valid pair, so which is 2 comma 2, right? Now we will see that this is a valid pair. Now if I move I again ahead, this is like again 3 is greater than 2, doesn't obey this. So we need to stop over there. Now again we can move our j here and then do the entire comparison from start till j point we are doing the comparison. So if you see this is basically nothing but for every j because of this constraint, we are starting from index 0 and going till index j over here, and we are seeing if there is any value such that nums1 of I is less than equal to nums2 of j. So we are checking this value every time, right? Now there is one more thing. While going over here, we are exploring all this value up to j, but there can be one more thing, that let's say my j is, it might have some more value. Let's say it is having 4, 9, 10, and so like that. Okay. Now what is this index? 4, 5, 6. Now for this value, if I say this index is 6, I have to go till index 6. But for in nums1, there is no such index 6 exist, right? So we have to, the constraint is I should be less than equal to j, and I should be less than n as well, where n is, let's say, nums1 of size. So we have to obey this, and this is the straightforward, solution for this approach. So I can just, quickly code this out. So what we are doing is, for index j equal to 0 till j less than m, where m is, let's say, size of this array, and for I is equal to 0 till I is less than equal to j, and additionally we need to check if I is less than n or not. Okay, so for this two value, we are checking if our nums1 of I is less than equal to nums2 of j or not. If it is, then we can update our answer, this max distance. Okay, let's write it that only. Max distance to be a max of this max distance, comma, j minus I. This is our value. So this is it for this. So this is the approach for this problem. And if we see that there can be a slight optimization that can be done if you clearly observe, you know, since problem has told already that this is a decreasing array. It's decreasing this way. So now just think of a case where I am at this index, let's say 10, and I know, or maybe let's take this index 10. I know that, sorry, my bad. Let's take this index 5. Okay. Now for this index 5, I know I started from here. It is greater, greater, greater. This is equal, right? So now for this for this value 5, here we have found one value which is less than or equal to that value. Now if I go in this direction further, definitely this value will be, you know, aligned with this condition, because it is decreasing order. But to get this value maximum j minus I, the maximum difference, it would lie in the first value itself. We don't need to move ahead, because as if we move ahead, if you say what was the difference here, it is 4 minus 2, which is 2, right? Now let's say if I would move here 3, then 4 minus 3 is 1. So every time when I'm moving, my index, the difference is basically decreasing. So to keep the maximum difference, we need to explore till the first point where we find our answer. So no further exploration is needed. So for that case, what we can do here is we can break from here. Once it is found, we know that further we are not going to find any maximum value. So this was actually a slight optimization over here. If you see, this is a slight optimization. Okay. Now let's discuss the time complexity for this approach. So if you see time complexity, so for every j and I we are exploring, all possibilities more or less. So it is m into n. And space complexity, if we see, so we are not keeping any additional, we are not having any additional array or something. So it is O of 1. So this is the time complexity. But if we look our constraint, which is 10 to the power 5, so it would be 10 to the power 4, so sorry, 10 to the power 10 altogether, so it won't pass. So we have to further optimize this solution. Okay, so if you look the further optimization, then what it can be done. So here if you see, what we are doing is we explored all the, you know, values in this second array, and in first array we are trying to find the first value which is less than or equal to that value, right? So first value less than or equal to this value in this given array. And if you see particularly from where till where we need to find is from 0 till the value j. This is our range for which we need to find, right? So what we can do is we can the second loop that we are doing, right? We can simply have a binary search over here. We don't need to uh, linearly search for this value. So if we turn this portion into binary search where our range is basically 0 to j, or we can say 0 to minimum of j or n minus 1, because we know that it can exceed, so 0 to n minus 1. And if we do so, we would be able to optimize this solution further. So I hope like the general binary search approach everyone knows. So I would be just, coding that out for uh, a quicker, thing. So this would go till m, and so our low pointer could be at 0, and high pointer, as we discussed, need to be minimum of j comma n minus 1. Okay, and we run our while loop the standard approach, that is low should be less than equal to high. And here if you see, we need to calculate our mid value, and mid calculation normally we know how we do it, minus low by 2. So I hope you know about this, why we do this. And this is basically to avoid any integer overflow sort of thing, for having a bigger integer. So yeah, and if nums1 of mid is less than equal to nums2 of j, so if we find our value, so possibility is this is less than or equal to, right? For example, in this 5, right? Let's say we came to this value 2, for example, you know, then this 2 is a right value, right candidate, but there can be possibility that before 2 also there exists some value which would be the right candidate. So we need to explore on the left side of the array, right? So what we would do is, one is like, since it can be possible, answer, so we can update our answer variable over here as equal to max of answer comma j minus mid, and we have updated our answer. And since we need to move towards I mean explore left part of it, so we can move our high pointer to mid minus 1. If that doesn't, if this is not the case, then we need to explore the remaining half. So low is equal to mid plus 1, the remaining right half. So this is our binary search approach, and at the end we can, simply return the answer. So if you see, a time complexity for this approach is, we are having this outer loop, but this one we have optimized. So outer is, let's say, m, and here we are doing log of n times. So this is m of log n. And space complexity, we have not taken anything additionally, so it is O of 1. So this is the time and space complexity. Now this would basically pass our constraint, because it's just 10 to the power 5. So if we do, 10 to the power 5 into log of 10 to the power 5, this multiplication, 5 will, if we have this base 10, 5 will come this side, 5 into this value, whatever it is. So altogether this will pass the constraint, it's less than 10 to the power 8. So uh, this will pass, but there is the most optimized solution for this problem, which is using two pointer. Okay, let's solve this problem using two pointer. We'll keep this pointer j over here and this pointer I over here. Now we'll do our simple comparison where we'll see, if nums2 of nums1 of I is less than equal to nums2 of j or not. So this is our simple condition. So in this case, this matches, it is less than 100. So index difference j minus I is 0. So we won't need to update our value. Now let's, since the condition matches, what we can do is, now let's think of this. If the condition is matching, right, which means 55 is less than 100, what we need to do? We need to move I or j. Just think of it. Now, if let's say if we move index I, which means I is crossing j, right? But our we have another condition which states that I should be less than equal to j, right? So we cannot move our right I because that would cross j. So when this value is satisfying, we need to move our j index. So we will do the same. Now our j index is here, I is here. Now we'll again start the comparison. If 55 is less than 20, no. If it doesn't matches the condition, we'll move our index I is here. 30 is less than 20 or not. 30 is not less than 20. So we again need to move our index I over here. Now we came to see 5 is less than 20, which means condition matches and we can move the j ahead. But here you might notice one more thing, right? That in this comparison, j is at index 1, I it is index 2. But why are we, not checking this again? Right? Because that is not obeying the rule. But there is, catch that if you, even if we have moved this value ahead, the thing is, if we see our difference, right? Whatever difference we might have calculated, let's say from here, it is, or let's say might be from here. So it would have, let's say 1 minus 0, which is 1. For example, we might have got this answer. Now, in this case, let's say I move this ahead. Okay, what would my answer be? So j is 1, I is 2, it is going to be minus 1. So which is automatically going to be less, even if we move our I ahead. So that is why we don't really need to, worry about this situation where our I is crossing, this value j. Now we see that, since it is less than 20, we can, since this condition is matching, we can move our j ahead. So I would move my j over here, and now again my I is here. I will do the comparison. I would do my comparison. Okay, so after doing the comparison, you see 5 is less than 10, right? Now we would have our value computed. So again, index 2 minus 2 is 0. We don't need to update. Now we can move our j ahead. J is at index 3. Okay, now if we see that 5 is less than 10, yes, it is less than 10, then again we would move this value ahead before computing the answer. So 3 minus 2, that is 1. So our answer is now updated to 1. Now I come to 4. 4 I see it's 5, value is 5. Is 5 less than or equal to 5? Yes. So the index difference that we see is 2. We need to again update an answer to have the maximum. Now if you see, j has moved ahead. So it's done. We have computed all our answers. There is no further comparison that we need to do. So on the way, we have considered all the possibilities, because everything after this would be smaller, and the values would be smaller for sure because it's a decreasing array. And indexes, if we consider this, it would give me the minimum sum. That's why we need not to consider this. So this way, like two pointer approach would work here. And uh, Yeah, that's all. And I can just, quickly write the code as well. So our I would be at initially index 0, j would also be at index 0. Now our while loop, it can run, I till I while less than n and j is less than m. We have this comparison, if nums 1 is of I is less than equal to nums 2 of j, then we need to update our answer, max of answer comma j minus I and j plus plus. Else, if this matches the condition, we simply need to move our I, and at the end our answer would have the updated thing, so we can return answer from here. So this is, yeah, it about this solution. Let's discuss the time complexity for this approach. So here we are exploring both the arrays. uh, at max what can happen is, this I need to explore till here fully, and this j also need to explore all till the end. Because let's say if here would have some different value, here also different value, here it would have, let's say, 5. So j need to definitely come over here till the end, and this I also need to explore till here to find the value 5. So for that reason it is of n plus m. And space complexity, again we are not taking anything additional, so it is of 1. Yeah, so that's all for this problem. I hope you like this video. Thank you for watching. Stay tuned for the next video. Thank you.